Welcome to the Ontario High School podcast. This is dealing with density here in the subject of chemistry. And this is density part 4, and we're going to step up the difficulty level a bit into what would be considered an A-level density problem. Now, as a caveat, when we work through this problem, I want you to try it each step of the way. Try to complete the problem before you move on to the next slide. See how far you can get. Hopefully you'll solve it at the first slide and not need any assistance from me. But at each step we go, if you run into a wall and need to continue the podcast, just go on to the next slide and there will be some hints there on how to continue. But at each step, if you would do your best to try and complete this before I do, that would be really helpful to you. So let's see how this goes. Okay, here's the problem, and I have it labeled as a step-up problem because it's going to be a step up in terms of level of difficulty from anything we've done so far. So we have a 32.60 sample of a solid is placed in a flask. Liquid benzene, in which the solid does not dissolve, is added to the flask so that the total volume of the liquid and solid together is 100 milliliters. The solid and benzene together weigh 102.72 grams. The density of the benzene is 0.8765 grams per milliliter. Determine the density of the solid. Now, the first step here, I'll give you a hint, is to set up a data table. And in this data table, you need to account for what's happening with the flask and also what's happening individually with the solid and with the liquid benzene. So if you will do that, set up a data table, and go ahead and try and solve this problem, and we'll see how you do. Now, if you get stuck at some point, just move on to the next slide. I can tell you in the next slide, I'm just going to show you what your data table should look like, and if you get stuck, you may want to go there and make a comparison. Welcome back. Hope you got a long way, maybe even to the end of the problem, but let's just take a look at what your data table should look like. The total mass of the flask contents is 102.72 grams. When I say that total mass, that's the mass of the benzene plus the solid. The total volume of the flask contents is 100 milliliters. And then we look at the solid. We know the mass of the solid is 36.20 grams. We don't know the volume of the solid at this point, and we don't know its density. And density is where we're trying to get. For the benzene, we know the mass of the benzene because we can take the total mass of the contents of the flask and subtract from it the mass of the solid, and that would give us 70.12 grams of benzene. The volume we don't know, but the density we do, and that's going to be real helpful to us. The density is 0.8765 grams per milliliter. So here's what we know and what we don't know. We don't know either the volume or the density of the solid. We don't know the volume of the benzene, but we have a mass and a density. So as you look at this data table, there's something you can do very easily on the benzene side of things because you have two of the three values that relate to density, and you can go ahead and solve for volume there. If I were to plan what I would call my next data acquisition, it would be to complete the data table on benzene. So if you're stuck and haven't got to the end of the problem, try that. We're going to use a simple factor label conversion to find the volume of the benzene. So we're going to take the mass of benzene, 70.12 grams, and multiply it times the density of benzene flipped upside down and used as a conversion factor. So we have 1 milliliter of benzene on top over the 0.8765 gram mass of benzene in 1 milliliter. So when we do that, our grams will cancel. We're left with milliliters as our unit, which is a unit of volume, and we get 80.00 milliliters of benzene as our answer. Once we've found the volume of benzene, it's a good idea each step of the way as you acquire more data, whether it's through calculations or some other means, hopefully through calculations in this case, what you'll want to do is update the data table. When we do that, you'll notice that we have everything we need for benzene. We don't have anything left to solve for there. But for the solid, we still don't know what the volume of the solid is, and we don't know what the density is. Now, as you look through your data table, check out the flask volume, because you have the total volume of the contents of the flask, and you have the volume of one of the two contents of the flask. So your next data acquisition plan should be to go after the volume of the solid. So try that. Okay, here we're going to find the volume of the solid. We know the total volume of the solution is 100 milliliters, and when I use the word solution, that's actually an improper word. I should have used here the total volume of the contents of the flask, because a solution would imply that something's dissolved in something and nothing is dissolved here. The benzene and the solid are actually in separate phases. So if you would scratch out that word solution and just use the total contents of the flask instead. The volume of the benzene is 80 milliliters. So we're going to go ahead and take the total volume of 100 milliliters minus the volume of the benzene at 80 milliliters, and that will give us the volume of the solid, which is 20.0 milliliters. Now, solids generally, we try to report the volume of a solid in cubic centimeters rather than in milliliters, and one of the happy facts is that 1 milliliter is equal to 1 cubic centimeter, so we'll report the volume of the solid as 20 cubic centimeters. Now that we have that value, go back to your data table and fill in, update your data table, and then you should be able to key in on what your next step is. So go ahead and try that. Okay, we are looking at our updated data table. For the flask, we have its mass and total volume of the contents. For the solid, we now have the mass and the volume. We still need to find the density. For the liquid benzene, we have the mass, the volume, and the density. So the only thing left to solve for is the density of the solid, and we know that density is equal to the mass of the solid divided by the volume of the solid. We have those numbers, so we can use our density equation, D equals M over V, to solve for that. We finally have enough information to solve for the density, and it's a simple solution now. Density is equal to the mass divided by the volume. So we have 32.60 grams of the solid divided by 20.0 cubic centimeters of the solid. We're going to report our answer in 3 significant figures because of the 20.0 cubic centimeters. And the units here do not cancel, they get carried through. And we know that mass per unit volume is a density unit. So we have set up our equation right when our units end up like this. So 32.60 divided by 20.0 gives us a density of the solid as 1.63 grams per milliliter. Now, this problem is not a real difficult problem if you use a data table, systematically attack what you don't know in that data table based on the information that's available to you. If you work through this step by step, you can get to the end. If you stare at this problem, don't do a data table, don't organize your thoughts, this is going to be a difficult problem to do. A-level problems will normally require you to do several steps on your way to solving the problem, not just one step. So this has been a multi-step density problem. I hope you were successful with it. You'll see more like this if you want to do A-level work. We've come to the end of the Density Part 4 podcast, where we took a density problem that's at a little higher level of difficulty than what we've done in steps 1, 2, and 3. I want to leave you with a quote by a great author, contemporary author, by the way, who's still living. And the quote is this: "Well-timed silence is the most commanding expression." Thanks.